All right, so let's look at what I'm talking about here, and with the first thing we'll look at is just the notation for an inverse. Okay, so we'll look at inverses of functions here. So we should know here, function notation, we usually have f, so we say f of x. All right, now when it comes to the inverse here, though, all right, and we're going to look at how we find the inverse in just a minute here, but the inverse of that function f of x, the way we denote that, do y'all remember this maybe? It looks almost like that, and it's you do f, it looks like to a -1 power of x. Y'all remember that now? Okay, that's how you denote the inverse. Now, you don't say f to the -1 power of x. It means that's the inverse of f. Okay, so that -1 is just cues you in that you're talking about the inverse. Now, when it comes to finding inverses, it's pretty simple. We're going to do one little problem here that might challenge us a little bit, but for the most part, what we're going to do is just in 2 steps. Okay, so you take your function here and you swap x with y. You just switch the variables, no nothing else. Okay, no coefficients, no exponents. You just take your x and y and swap it. Now, problem with that is usually it's going to be written as f of x. So we've got to realize, well, if it's f of x is just a fancy name for y. And we can rewrite it as y equals. Now, and then the other thing here is you solve for the y. Now, one thing that I'm not really just going to write here, really the last step is you don't want to leave it in a y equals form. Okay, since we're talking about inverses, what we'll say at the end, instead of like y equals and then our answer, we'll write it as f inverse of x. Okay, so it looks like the inverse. It just doesn't look like an any old function. So, we'll just rewrite the answer so that we're using that inverse notation. Okay, let's look at some. Okay, so let's start off with a linear one. Linear ones are usually really easy. Okay, so like 4x minus 7. So when I say linear, that means the graph of that would be like a line. Okay, it's just like slope-intercept form. All right, so let's do what we said here. Let's take it and let's swap x and y and then solve for y. Well, there's a problem there. There's no y there. So what's up? Well, f of x is the same thing as y. Okay, so I'm going to write it as y equals 4x minus 7. So now we can swap x and y. Now, when I do the inverse, I don't want to write the next thing like right underneath right there, because that somehow implies that that's the same equation, and it's not. The inverse is an entirely different equation. So I'm going to write it over here to the right and swap x and y. So we'll get x equals 4y minus 7. All right, so just see what happened there? The only thing that changed was x and y. I didn't change any of the numbers around. Okay, now, so I've swapped x and y. Now let's solve for y. So that's fairly simple. Y'all can do that. All right, how do I solve for y? Yeah, add the 7. Okay, what else now? Yeah, divide by 4. Now, when you divide the left side by 4, it's kind of up to you how you want to show it. You can divide each individual term by 4, or you can do it like that by 4, and that's kind of the way I prefer. So we get y equals x plus 7 over 4. Now, x plus 7 over 4, that's our inverse, but let's denote it like an inverse. Right there, it just looks like a function. So you're really saying, since y equals 4x minus 7 and this, that they're the same thing, and they're not. So how can we show it's the inverse and not really the same as this function up here? Right, you write it that notation. So we're going to write f inverse, which looks like f to the -1 power, and then equals x plus 7 over 4. So that's the way I'm going to write my answer. Okay, does that make sense? Yeah, it is pretty simple. Did y'all do this with Coach Free? I didn't think y'all got to this point. You did? Okay. Yes. Yeah. Yeah, and you did it right. Huh? You went home and did that lesson, I'm sure. All right, let's look at some more. Now, that was a linear one, so, it wasn't that hard. Let's do one that's like a cubic. And we won't really do a quadratic. We'll talk about why we really don't find inverses of quadratics kind of on Monday when we start talking about graphs of it. Let's look at this one. Okay, let's do a cubic one. Do a couple of cubic ones. So first off, so we can swap x and y. Let's write it as y equals. Okay, so now y'all swap x and y for me here. Call out what's it going to look like when I do that. All right. I'd go with that. Let's do it in order though. X equals, all right, 1 minus 7 quantity cubed. All right, now let's solve it for y. Right, you got to take the cube root of both sides to get rid of the cube. So we'll get cube root of x, and then that cube root is just going to undo the cube, so it's just going to be y minus 7. All right. Now, let me ask you this. Should we say plus or minus cube root of x? Because we do cube root on both sides. It's a cube root. No. If it was an even root, we would. Okay? And this is why I said we wouldn't really do quadratics, because really what happens is quadratics don't have inverses. Okay? Their inverses wouldn't be functions. Right, yeah, just add the 7 over. Okay? And cube root of x plus 7. All right, now let's write it in our fancy notation. So f inverse here is cube root of x plus 7. Okay. The ones that can get a little bit challenging are the rational ones. Okay. Rational as in fraction. So you get one rational one that's like super duper easy. You see one of these, and the next time you see one like this, you're not going to have to show any work. Okay, because they're unique. They're very unique here. So on this one, let's swap x and y, or let's write it as y equals first. Okay, and then now let's swap x and y. So we would get x equals 5 over y. This might be a little bit challenging the first time you see it, but let's figure out how can we solve for y. There's a couple ways to do that. By what now? By 5? No, I'd say multiply both sides by y, because it would get rid of the fraction element in the problem. Does that make sense? You get rid of the fractions if you multiply both sides by y. All right, another option is you can take x and put it over 1, and what am I thinking there? Cross multiply. Okay. Now I'd rather you think of just getting rid of the fractions, because it'll help you out on the harder problem. So we're going to multiply both terms or both sides by y to get rid of the fractions. So that'll go away, and it's not a fraction anymore. All right, and then on this side, y times x would just be xy. All right, so divide by x now. And wait a minute, this is like deja vu. Have I been there before? What? Are you serious? Yeah, I'm serious. It's the same. Okay? So when we see one like this again, we're not going to go through that, are we? Okay? So if it's a simple rational one, really, simple little rational functions, their inverses are actually the same. Yeah, but then it wouldn't be all fun. Okay? You didn't have that, oh, that's pretty cool. Hey, why do we do all that? But now you don't have to do it anymore. Okay? Now, let's look at a rational function though that's not cool like that. And this is the one that I'm talking about, I'm like referring to, that's a little bit challenging. Okay? So I'm going to take that same one, like 5 over x, and I'm going to add a 2 to it. Yeah, boo. Yeah, this one's going to suck. Okay, yeah, it's put in there. Alright, so that plus 2, if that plus 2 wasn't there, it'd just be 5 over x would be the inverse. So now let's look at it. So let's see, we got 5 over x plus 2. Let's write it as y equals there. Now let's swap x and y. So we'll get x equals 5 over y plus 2. All right. Now we'll do just like we did the other one. We'll get rid of the fractions. Okay. So we're going to take each term and multiply it by y. Right. And so that's what goofs it up when you're multiplying that 2 by that y. So you get xy equals, those y's go away, and then 2 times y would be 2y. So that presents a big problem here, because now we have 2 y's in the problem. Okay, so let's see if you guys can think here. All right, what's maybe something we can do to get that down to 1y? All right, divide by y. All right, now the problem with that, it's going to get rid of them, but then you're going to have to divide that 5 by y, and then you just be back where you started. You just chased your tail. You just went in a circle. Okay? No, figure it out. Okay? So, all right, let me ask you this. If I have this, what will we do there? We subtract 7y, and then we could put those two together. Same concept, okay? Except for we're not going to be able to put them together. So I'm going to take this 2y over and try to combine it with that, even though it's not going to combine. So we'll get xy minus 2y equals 5. Okay, but the problem is, they're not like terms, are they? If that was like, 6y minus 2y, it'd be 4y, and that would be it. So here comes like the really, really challenging part. We have to really think outside the box right here. What can I do? See if y'all can figure it out. You got 2 of them there. No, because then you still have 2 y's in the problem. No. Watch this. See, both of them have a y in it, right? So how about factoring it out? If I factor it out, then there's only one of them, isn't it, right? Now, see what I'm going there? Okay. So you can get y times x minus 2 equals 5. Now the equation only has a single y in it. Okay. So now, what would I do to solve from there? What's y doing to x minus 2? You're multiplying. So divide by x minus 2. Okay. Yeah, I told you this one would be pretty challenging here. So you get y equals, it'll go away, 5 over x minus 2. So there's my inverse. Okay. 5 over x minus 2. Okay, so let me kind of help you out with this a little bit. Be sure you got this example down. This is going to be very similar to the problem I'm going to give you in a minute. It's going to be number 25. Okay, so and maybe look back and study this problem when you do it. And let's kind of look at what we did here, sort of step by step, and make on our notes, okay? So when we went from here to here, you're eliminating the fractions, right? Okay, so that's a start. You eliminate the fractions. Right. And the next thing, but you're getting the y's together. Okay, so we'll write here y's on same side. All right, and then what was that magic step right there? Factor. Yeah, that was the really key thing here, was to factor out a y. Yeah, it's not really that bad, okay? But it's pretty challenging. Okay, now on the sheet that I'm giving you, I had TBA over there, so I'm just going to write it up here. What you're going to look at is numbers. You can write this down when I get you your sheet here. 11 through 25, just the odd. Yeah. Yes. As long as you haven't finished your graphs, be sure you finish up your graphs. Okay. Y'all get started with this. You probably knock it out real quick. Okay. Let me give it to you.